Y'all ready? Can I do a quick announcement? Absolutely. In general, welcome back to the F-sharp Music Group. I love the new location. It's totally awesome. We'll have many new thing here. One announcement, I guess, that I can think of is the Haskell there's a Haskell Codeathon on the 4th of next month. Beginners are welcome there, so it might be fun to drop by and hang out for a while. I'm going. And if anyone, I also want to say, if anyone ever has like job announcements, like someone who's looking for F-sharp employment, I would love if like have it be open announcements essentially. For I haven't done this in the past, but I think it makes sense to have anyone who has like something to announce, like a new F-sharp project they've worked on, or any kind of public release of something, or just they're looking for F-sharp hires. Just say something, and then that's cool. All right, well. I'll give it to Will Smith here to show us about Quake.
Hello. Everybody hear me okay? All right. So my name is Will Smith. I am from Nashville, Tennessee. I've never been to New York, and I've never done a talk like this one. This is kind of a very different talk than what some people can be used to. So I guess let's get started. So what is this about? For all you saw the description, Quake III, F-sharp, and then Will Smith, and then that's like the only 3 descriptions that you really had. And so what is it really about? Well, Quake III for enterprise. We can leverage F-sharp, object-oriented programming, with Quake III, and we can use it for any framework. We can definitely take control of this using OO and Quake III and make this powerful. Absolutely not. That is not what that's about. So what is this really about? Well, Quake III, if you all don't know exactly what this is, it's a game made in around 1999 by id Software. It is written in C, and it came upon me that in order for me to learn functional programming, I needed to do something real. I wanted to do something where I can actually physically see the benefits of doing this and find out, is it really, can we actually use this in the real world? And if you can do it in a game of this magnitude, I can have this cushion of like, yes, we can. So, first things first, the performance, if anybody's interested in what the performance is, it's not what you want to worry about right now, because it will definitely vary with all the weird things I'm trying to do in order to get things to work. That should be like the least concern. And the entire code base is only 5% complete as far as me going through it. And that's actually kind of being generous. There's a lot of work there. There's a lot of stuff that you got to do in order to port this stuff over. It's a lot. And it's a big undertaking that I'm, I guess, trying to do, but I really don't know what else I would do, because I kind of really like this stuff. So I'm going to try to do everything I can to just learn from it. So this begins the journey. Where did everything really begin? Well, C++ just wasn't cutting it. I studied it for 8 months, and it just was not. It made me just feel awful about myself, because everything was just exploding. You can't read what the errors are going on. Standard library wasn't exactly my cup of tea. So I moved on. And I joined this open source project, just ran by 1 or 2 people, a real small community. It's called RTCW Co-op. And what that is, it's Return to Castle Wolfenstein. You can play single player and play with your friends. And that was, I really like co-op, and I love multiplayer games. And since I was moving away from C++, I came into C. And what I found was, it was actually kind of elegant, because I have data and behavior, and they're completely separate, and they're not tied in. Because that's what OO does. It ties in all your state and all your data, and your behavior all together. And it doesn't really start to feel very good. So that's why C actually started to feel right. But I did something kind of weird. I tried to write C functionally, functional C, by just doing, mutability, and that's it. And just that one simple constraint, I actually saw things in my code that felt really concise, and it wasn't even that much. It was just a very simple constraint that actually made a huge difference and a huge impact. So at that moment, I thought, you know what? I need to find a functional language at this point. But I want something that is functional first. And so that's where I found F#. Now, what made me skeptical about F# was mono, because every time I hear something on Hacker News that says, yeah, .NET's not cross-platform, it's not any of this, and mono doesn't count. I'm like, well, why doesn't it count? People are saying, performance is bad, or, it's still buggy. Well, I started researching this, and I found that actually it is kind of performant. Like you can, there's a few sites that you can go to and see benchmarks, and it's actually not that far away from C++. And so I'm like, okay, I feel more comfortable about this than before. And another side is, I can use this at work, because we use Xamarin, we use C#, and F# can work on iOS and Android. So that gave me, more incentive to actually start doing something with it. So I made a few sample projects, just kind of getting familiar with the language. But I really want something real. I wanted something really deep and really, really difficult, just so I can know, can this really solve complex problems? And so that's what started Quake III. And now you're going to see a demo. Now, how do you know if this is actually running F# code? So, here is a weapon. As you can see right there. And here is some code that actually does the calculation for this weapon. Still get IntelliSense. And now it's right there. And I updated this on the fly. And so this is running F# code. So we get that idea out of the way. Now it's back. Now let's do something different. Since we can take advantage of this, what else can we do? Let's go to Snatch. So here is my third-person character. And I have another script file called players. I want to do something a little strange. that doesn't actually make a whole lot of sense, but it's kind of fun. Now his head's off his head. So now every character is going to have this. Uh-oh. Wow. Okay, with that in mind, we can make his head disappear. Now it's gone. Where'd it go? I want a new head. I think this will be a good head. There we go. Now we're ready. Come on, Don. Come here. So I think that gives you an idea of where I want to go with this. Now, fit. So now the question is, how does this work? This is using the F-sharp compiler service that I think it is recently been in development for a little bit. And I started digging around and I actually saw that you can embed F-sharp Interactive in any application that you want. And so I was able to do this in my project. So how does it actually work? So let's imagine a function that is completely pure, doesn't cause any side effects. The input you give it is the same output you're going to get. And with that in mind, you have this function, calculate weapon position. You pass in cgame, which stands for client game. So there's some things on there that you can have information about the state of which the client game is actually in. And so you can get information off of it. And it returns a tuple of two vector 3s. One of them is a position, and the other one is an angle. So with that in mind, I'm going to declare a variable that will just contain a function of that type that I just described. And all it's going to do here is just return 0 and 0 as a default. And then inside the script, I can use the preprocessor, if this is in F-sharp interactive, or if it's not, I want to have these things for me to use that I want to actually compile in the game itself, and things that I want the F-sharp interactive to modify. And so all of this is actually contained within the same file without having everything separate. So this is how it would look like when you compile it, not running in the F-sharp interactive. And that's all it does, is call that variable of that function type that can get set by F-sharp interactive. So this is almost verbatim from the F-sharp compiler service documentation. This just shows you how to just get it up and running. FSI, EXE, non-interactive, all this stuff. If you go into F-sharp compiler service documentation, it'll tell you what each of these things are. So this is just kind of like standard, you got to do this, and then you can go ahead and start using what you want to do. Now the actual way of figuring out if something changed or not, I have a async that's going to continuously run and sleep every 10 milliseconds, and is going to check and see if that weapons FSX file has been changed or not. If it has been changed, then we're going to evaluate using FSI session eval script. And that's all you have to do. It'll take care of the rest for you. And inside the FSX, it'll call this to get your new evaluated function set. So the compiled code can actually pick that up and run. So this is kind of, I think it's kind of neat that we can actually do this and run code on the fly to figure out what is going on. A lot of stuff in game development seems kind of scary at first, at least for me. And I hate having to change something, recompile and run, and go to that same point to see what happens. Whereas I can just change the code I want and save it and immediately see the effects, so I can actually learn what this thing is doing. And I see there's so much benefit in doing that, and so much time you can save. I hope there's a future in this, and that this can be improved. There are a few things that I noticed when doing this, where F-sharp interactive can actually cause the game to actually pause intermittently at certain points. I'm not exactly sure what that's caused, but this is all still being developed, but it's really interesting to see what you can do already. So, as far as the code base concerns, and the experiences that I've had, what are the benefits of functional? Where can you actually see them? So two things. Mutability. Variables do not change, and that simple constraint can make a huge difference and a huge impact on how you write and think about the problem that you're trying to solve. Just that simple constraint. And there's referential transparency. That means same input you give it is the same output. That's it. Just that rule. And so how will that actually affect your code? So the first thing we're going to do, we're going to look at some C. Because I want you to understand, I want to try to explain as best I can what is going on. So I hope this will make sense. So here is a original C function that was in Quake III, probably been there since 1999. This is called rcall_localbox. To give you the simplest explanation of what this function actually does, all it does is take, in your view, am I seeing something or not? If I'm not seeing it, don't send it to the graphics hardware. And that's all what this function does. It does that calculation. But I'm not going to show you how the calculation works or anything like that. We're really just going to look at what this function actually depends on. The next one you see, this is just right after that declaration. And then you see some things. There was vector 3 bounds. And there's other variables there, transform, dis, thrust, back, front, back, okay. But where in the world did R no call come from? And where did that come from? Where did that come from? It's like it just kind of appears out of nowhere. This is a global state. And to describe what this thing is, TR, think of it as like a global state variable that's just sitting out there and anything can access it at any point in time. And then OR just stands for orientation of something. You don't know what it is, because it's just like, here's global state and off of its orientation. Well, what in the world is that? You don't know what it is. You just know that this thing needs it for some reason, but you don't know where it's being set, where it's coming from, or why. So we're going to focus on just this one example, tr.or. So going up and seeing where that our co-local box is being called, this function, co-model, calls it. And don't worry about exactly what is going on here, because that's not the thing that I'm trying to show. Here is calling our co-local box, and in the whole function, you're not seeing everything, but when I've looked through it, there was no sign of tr.or being set or any mention of it. So that means co-local box depends on tr.or. Going up further, where is our co-model being called? Being called by this. And what's this doing? Okay, it's being called there. And I remember looking at it. There was no sign of tr.or being set anywhere. Where in the world is it coming from and why? Still no sign of it. We don't know where it's at. And our co-model now depends on tr.or because that function below it that was calling it depends on it. So going up further, seeing where all this thing gets called. Now I think we found it. It's right there. And we're passing it as a pointer so it can get set. So when it comes out, it's going to be set with some value. Okay. And then here's that R at MD3 surfaces, which then called the R co-model and then called our R co-local box. Why in the world did they just not pass it as a parameter all the way through? You wouldn't even know that you would even need to set that if you were trying to reuse this somewhere else. You forgot to set it, so this just doesn't even work as you were expecting it to. You have no idea. You have to actually dig through the functions and find out. So some abstraction that is. Function signatures should tell you what the thing needs to do. It shouldn't be the order which things need to get set and not passed as parameters. It tells you what it should do. You need to pass it. Now, what have I done in F# in this? So, how I'm going about this project is I'm taking the original C code, and it's like, all right, here's the C function. And I'm just going to write it in F# and do the interops to call it, and so it can run it. And I want to write it in a pure functional manner where there's no side effects. Everything is referentially transparent. So this is what it looks like on my end. It's been modified a little bit in some way, but I'm at least passing everything as an argument. So now orientation is now being passed as an argument. You know what this function's dependencies are. It tells you right there. You know what this thing needs in order to run. You setting the global state, how in the world would you know that? This tells you what it does. This tells you what it needs. And going up further, where our model function calls co-local box, is passing in all those other states, like the actual global states being passed in. And when you start seeing that, you wonder, should I really be passing this giant state into this function? Is it absolutely necessary? And you start to wonder this, and it turns out that you probably do not need to at all. And you can start refactoring this out, possibly very safely, because now it's not going to affect any state outside the function because it's pure. It's not going to change anything. It's just a function. That's all it is. So to recap, the benefits of functional programming: it's easier to spot what things really need to be dependent on. Because you can tell by just looking at the function signature. It's right there. This thing does need the entire global state. This thing does need orientation. And with that, because this thing is actually ported almost verbatim, almost exactly the way the C code is, but in a pure functional manner, it actually doesn't, it does feel a little elegant, but it doesn't mean it is always going to be elegant or always shorter. But refactoring it and breaking it down is a whole lot easier than going the other way, looking at your imperative code and trying to break these pieces down into separate functions, because you don't know if you're going to accidentally change the state of something and then blows up something else and you don't know where that is. Especially in C, when you don't even know, whoops, I just changed the pointer and it ran over something and everything exploded and I have no idea what happened, just crash. So that is really the main thing about functional programming is side effects and state. It is so important. And think about when things are just changing willy-nilly just because they want to, it actually kind of scares me now that this kind of stuff has been written. Now this is old. Quake III is old, so they may have some reasoning behind it then, but the reason now is really not so much. We need to write safe code that has some guarantees in it and actually has constraints, and constraints are very, very important. The discipline of purity will give you this. And so, as you saw, I actually had an attribute called pure. It doesn't do anything to the compiler. It's just a contract somewhere in .NET framework that I use that just means that this thing doesn't do any side effects. And so, just as a discipline rule, if I know I wrote this purely without any side effects, I'll just throw that attribute on there. Now let's look at discriminated union. So, simplest example or simplest explanation I can give on a discriminated union, think of an enum type. And each type has data associated with it. And it's actually kind of true. So I'm going to show you some C. I actually found kind of interesting to see in this. Okay, big switch statement, some cases. Surf type is an enum, so it has the size of an integer. You're dereferencing it, seeing what the value is, and then they're going to cast it as a completely different struct to get the data out of this. So it's kind of interesting to see. It's like this looks familiar. This is old stuff that they were doing. I feel like maybe they were thinking like the right way in some sense. Of course, it's not safe. And the F-sharp version doesn't look too much different. You get pattern matching. You have a discriminated union, which is surface, and it has the subtypes, face, triangle, poly, and it has data in it. They're very similar. So there's the enum, bunch of stuff defining. Doesn't matter what exactly they are, just that you know it's an enum and it's defining stuff. Then you have the types. And notice that the very first one is the surface type. So that means when they pass this thing around as a pointer of surface type, when you dereference it, you'll get this first thing. And then hopefully no one would have broken anything in that whole process. It's not guaranteed at all, but they tried to have this pattern in there, which was really interesting. F-sharp version is not too much different. They did break out things into their own type and put them in places, but I think this gives a good point across. Now, C isn't safe at all, even though I love C to death, but C is definitely not safe. And I don't want to write my business logic in it whatsoever. I'm going to stay far away from it as much as possible. So, as an example, let's look at another struct from a completely different file. It's a completely different world. It has nothing to do with what you just saw with surface types at all. So here's one. It's called nyc-surface. Okay, what is that? Well, this thing is going to pick up surface data of the models of the game, and this is just the layout of what it is in the file, in the binary. And this is just how it picks these things up. And the very first one, called ident. Notice it's an integer. When this thing actually gets read, if this is actually a string, this will turn out to be IDP3, and that just means it's the version identifier, so they don't break anything in future changes. So they wanted something to identify this version of this surface. Okay, that's cool. But somewhere they decided to change it to the surface type in a completely different world. So therefore, when they do that, every time they load a model file, they change all the surfaces to be that. So therefore, they can cast it. Anyway, like in the switch statement that you saw, they can just case SFMD3 and then get this out. And this is how it's used. So a type that had like no association at all whatsoever to this other type from another file, they just said, oh, we'll just mutate it and make it work. Oh dear. I've actually had to spend probably 4 hours trying to figure out why something wasn't working, and it's because I didn't understand that they changed this. And it just is the middle of the file. You wouldn't even notice it as you're just looking through. It just changed. And that made a huge difference on everything in the program, like all of it. It's just, That's scary. Now C is very bad in this spot, but it is very interesting to see the poor man's discriminated union and poor man's pattern matching. It's actually interesting to see that they kind of thought that way. It was really the thinking that actually surprises me. It's like, oh, maybe they were thinking the right way. Then everything just went to objects, and that's when everything just went downhill from there. Now, we're going to look at how this stuff is actually put together. How in the world is F# calling C, and how is C calling F#? That's got to be both ways. So this is probably the most challenging part of this project, is trying to figure this out and trying to make it as simple as possible. And I'm still trying to find ways to make it simple, but what I got has been okay, but now it's starting to bite me a little bit because I don't know what I'm doing. So the first thing we look at is the project structure. You have your main executable, Quake III, is in the C folder. You got the F# folder. So you probably know where the different piece of code goes. You have the native folder, and that's just going to contain the original Quake III C projects. And you have this project called M. M was something that I decided to write a mono abstraction, because this is actually running on the mono runtime. It's not running on .NET, it's running on mono. And mono exposes a C API for me to use and consume. And there's a lot of boilerplate involved in just doing simple things like getting a method and invoking it and passing stuff to it. It's actually kind of like there's a whole process involved in it. And so I decided to write an abstraction to where I can just write one line and it just works exactly the way I want it to. On the F# side, there's your engine and your client game. That's as far as I've gotten. My focus has been the engine renderer. I haven't really been digging in too much into the client game or the game or the game logic. I haven't been focusing on it. I've been focusing on the renderer because I don't know anything about it. I don't know anything about linear algebra. I don't know any of this stuff. Well, how am I going to learn? Well, I got to do it. And this is my way of doing it. Good or bad, I'm having fun with it. And there's another one, Quake III utils. It's just tool separated. I decided I want completely separated from the engine. This includes, I want to load a model file or all the math, like basic normal math operations, are just going to be in there. I don't want to be direct. I don't want it to be directly tied to the engine itself. And then there's the launcher, and all this launcher is going to do is just start the engine. So now let's look at how F# actually calls C. So to call C, and just in .NET in general, you have to use pinvoke, or if you want to, if you're in .NET runtime, you might be able to use C++ and that whole area. And I haven't really touched on that, but since we're mono, we don't have that, so everything has to be through pinvoke. So pinvoke is just a way to call into an external function that is native to the operating system. That's just there's a convention for that. And this is just F#'s way of doing it. And so, not touch on this too much, there's things like suppress unmanaged code security. That, you throw that on there, that means it's not going to do some extra security features. So this function that you call will actually be a little bit faster. But it's not going to be very secure, but you don't really care because there's not really a whole lot of security when you're dealing with C and exactly what I'm doing. Things can explode and you have no idea what in the world's happening. And then anytime I write one of these, I'll just wrap it with something. Just so I can hide it, so nobody knows I'm actually calling that or not. And these aren't pure, these do call side effects, but these are things that I want to go ahead and call and like write some part of the system that I want to use. And so when doing that, I have to put in these two things, m export, m decl. Now, this m underscore, this is my little framework called m. I don't know why I called it m, but there it is, m. And these two things are necessary for when you actually compile a dynamic library on Windows. You have to put these things here so they can actually be accessible from the outside. Otherwise, you wouldn't be able to call it using pinvoke. And so this is just what it looks like. They're macros, and they're just going to be immediately replaced by the compiler. And MSVC and C-Lang and GCC, they have different versions of doing the same thing. And they're actually they do the exact same thing, but they're a bit different. And so you have to write your code to say, all right, if it's Windows, it's got to do this. If it's using the GNU C compiler, it's got to do all that garbage. Now, how this thing works, I don't know. I researched it, looked up on the internet, said, this is what you need to do. And I'm like, all right, well, I'll just copy paste that in there. Well, sure enough, it worked. All right, I'm not going to touch it again. So now we got C to F#. Now, how in the world is this called? So this is an example. Again, using my M library, my M mono abstraction, I have a macro that will do a bunch of magic for you. All you have to do is say, treat it just like a function, say minvoke new. You give it the assembly name of your .NET DLL. Then you give it the namespace. The module, so the F# module, where this thing is. And the function. Yes, this is the one calling call localbox. And then the output. And everything after that is variadic arguments. And it will determine how many arguments you have for this function that you're trying to be called. So you don't have to be explicit about how many. You just pass it. Then you start seeing things like, what in the world is mObject as arg? What is qm of bounds? Well, okay. Why do I have to do all this stuff and passing this around? mObject as arg, anytime it takes a mono object, and anytime I see if it's a struct, I need to unbox it. Otherwise, it just will not, it won't work, it will actually explode. So this is just a way, like a standard way I decided to do things, because I may change something to be a struct or a reference type, and this kind of like saves me from that so it doesn't explode. Now the other side, when you saw Q of blah, this is a convention that is there to look at a certain place in the .NET DLLs and see if it can call a function, and what those functions' jobs are changing from unmanaged types to managed types, and then managed types back to unmanaged types. And it's just a convention. So you don't have to write all this stuff continuously. It's just a macro that will build that up for you on C, so you don't even have to worry about it. They'll just take care of it for you. And this is something that you have to do before you actually call a function into the F# code, because you have a representation that is actually widely different from what is actually there. And you need to map it, essentially. And so this is just an example of just doing a vector 3. In Quake, a vector 3 of t is nothing more than a fixed float with 3. But on my side, I have a vector 3, and it's just a struct that contains 3 fields, x, y, and z. And so that's how I'm mapping it. And that's like the simplest example. Things get a whole lot more complicated when I'm mapping the entire global universe over to manage and then back over. And that is actually where I'm actually hitting tons and tons of problems doing that. So I may be thinking about the wrong way, I don't know, but this is how I've decided to explore these things. And I'd really like if anyone could give any feedback on like how we can actually make this simpler. Because I'm having like, I'm in a dungeon right now trying to do all this stuff. And then this is just, don't worry about what everything's up here. It doesn't really matter. This is just the abstraction, all the boilerplate stuff that actually needs to be done to call a method. So it's just a bunch of stuff, so you don't even have to worry about it. So now I'm going to show you another demo of what it is like to port a C function to F# and just see kind of what that process is. And so I'm going to go kind of backwards a little bit. You're going to see this thing already working, and then I'm just going to delete it and just rewrite it again so you can actually just see what that process is. But any other function that I just want to pick and choose, some of them are actually not very trivial. It can be complex and have these weird edge cases just because that's just the nature of C, unfortunately. So I'm going to duplicate these displays so I don't have to like hurt my neck. Okay, can everyone see that okay? That looks fine. Right. So here's a function called r_local point radius. Very similar to what the very first function I showed you, what it does. Is something there or not on my screen? No, okay, then don't draw it. Yes, okay, then draw it. That's all this does. It's just another path for it to take based on some criteria before it. That's all what this function does. But it doesn't matter, because I just want to just write what I want to write. So I'm just going to just delete this. And here is the # version. The F# version takes point, radius, orientation, frosting. Okay. So I need to write that. So usually I have to do something like this. I'm looking at both paths, trying to figure out, all right, this is what I need to write in order to call this thing. And so you guys can see this. and so I can see it too. So this is what you would have to do in order to call it. Say object. So mono object as on the runtime. I'm going to call m. Invoke new. And here you can see assembly name, namespace, static class, method, output, and the arguments. Renderer. It's in the main module. The method name is called col. Point and radius. And the output I've already defined before, called result. Now I need to pass these things in. Now where in the world could they possibly be coming from? Because they're not really there in this function signature at all. So in a lot of those cases, I have to go find which one it was I need to use. So I'm going to call m object as arg. So that's going to do, is this an object? Okay, that's good. Are you a struct? Okay, I need to unbox you before I pass you in to this function. So it's a vector3 type. It's called point. Do it again. And this is just to show you what the process is like. And I'm not showing it this is the most elegant way or the most perfect way. It's just like, this is what I have to do. And somebody please help me so I don't have to do all this over and over again. And this is radius. I'll have to pass it in there. Sure enough, I remember you have to use our TROR again. Where in the world was that coming from? That is awful. Now for the last one is the C bar. All right. And then the result coming back, look at what the signature is. It's going to return at the very end. It's going to return a col type, which is nothing more than an enum. Is this thing visible or not? And that's what its whole purpose is. And so since I know it is a value type, I need to do the unboxing. There is that. It is the name.
I think you're missing a paren on the orientation R on the right hand side.
Thank you. All right.
I got the first one too. The vector 3.
Yeah. into this process of actually doing this. There we go. And we're going to build. Okay. That's what you have to do in order to call a function. If this doesn't work, it would probably have exploded at some point. Could be a null reference because you're interacting with something completely separate from the runtime. So we know that's working, otherwise it would have crashed. This function gets called quite a bit. So that's just that process. Now I just wanted to show you. As far as the code that's concerned, there's actually quite a bit involved in this one in particular, and any of the functions that I have tried to rewritten are actually quite involved and could almost be a talk in of itself for each function, which is it's not as crazy as you think, but it just takes a lot of time. It could take me an hour to make sure that this function could be right or wrong if I were to rewrite C to F#. But that's just the process that I have to do in just order to call it. If I know that my F# code has that correct signature and has that correct logic, then I can go ahead and call it. So that's just what I wanted to show everyone. So now I want to get rid of the duplicating and go back to different modes here. So now we're getting close to the end of everything, but I just wanted to touch on these few things. It's like, how am I handling the math involved in this? Am I using a third-party library or not? Am I using something like OpenTK, or OpenTK is an open toolkit that contains OpenGL, OpenAL, and OpenCL, and some basic common math functions that you would use. I thought about using something like that. And I just wanted to see what an F# version of writing your basic linear algebra functions do. And actually, could you even make those implementations elegant in of itself? Because if you have those elegant, imagine what you could do when you actually start consuming it. So this is an example of creating a vector 3 type. It's a struct. It's sequential, so the order of memory will be the same. And that's that's absolutely necessary, especially when you want to pass this to graphics hardware. Things need to be in order. And then the functions that are off of this isn't a module, a vector 3 module. And these are just standard basic linear algebra functions. And I'm inlining them all. So what does inlining do? Well, this is something that C# doesn't have, is inlining, especially for math. And each time you do a math operation in C# or using a C# library, it has that function overhead of just doing a simple computation. But in F# you can do inlining. So wherever you call this function, the F# compiler will just take that and just put it right there instead of actually calling a function. So that function overhead goes away. And so that's why I wanted to write my own little math library that is still, it's very naive, let's say, but I'm learning a lot from just doing this. And I think this is just important, especially for game engine itself. You don't want that extra function overhead, even though it may not make a difference now. In the future, if everything was just inline, you may save that 1 millisecond, because you have a game that needs to run at 16.67 milliseconds in order to get 60 frames. If this could save you 1 millisecond, totally worth it. Absolutely worth it. I also decided to bring in units of measure, which is, oh my gosh, so beneficial actually in one particular spot. The degrees and radians. When somebody is calling into a math function, oh, I'm sorry. Yes.
On your previous slide,
Yes.
Math functions. Similar to linear algebra, just want to make sure, usually addition subtractions are done first and then the multiplications. There's one like on the line 4-ish, 5-ish. I just want to make sure that still applies in this stuff, for example.
Like the order of operations?
Yeah,
Yeah, they still apply. If,
Because usually you know a lot of parentheses, you know, they make
right.
lists,
I did have them as parentheses, actually, as before. I got rid of them because I hate parentheses. I hate parentheses. I can't stand them. That's why I can't stand lists.
This will make sure.
But yeah, it does become more clear if you do it that way. So back to the units of measure. This is a conversion between radians to degrees back to radians. And it's very useful if you have a function that you want somebody to call whenever they need to do some type of rotation around an object or entity in the game. You want to make it really clear that, yes, you need to pass in degrees, or you need to pass in radians. They need to know that. Otherwise, they could be passing in degrees that required radians, and they had no idea. And they could be spending an hour trying to figure out why this thing is not working properly because they realized I was passing in the wrong unit of measure. Well, darn. And so that's what it looks like using it. We have just a function, takes an angle, it's a single precision float, type radian. And over here is a function, and you can see degrees to radians. Type inference is going to make this angle be degrees here. So that means when anybody's calling this function, they need to pass in degrees. And then below, in the standard linear algebra function up there, it'll do the proper conversion for you. And so even when reading this implementation of how this works, you're like, okay, I know that this is going to be degrees, and it's going to be converted radians and pass through. And just to give you an idea of what this function does, it's just, here's a point, here's another point, rotate it. Where's it going to be? As all this, what this function does. Next section is parsing binary. So I'm having to take binary, like the original binary files of the game, models, maps, even script shader files. And I need to be able to parse this out in my own version, because if I try to write what the C version was doing into F# and kind of make it the same, but still purely functional, it ended up looking ugly and it feels horrible. So I have to kind of do it from scratch. And so that's why I have like a separate project just for consuming those content files. So this is just going to be just a run through. This is based on something that I'm still, again, very naive on this. There's a library out there called fparstack, and it's just an API and a way to parse, really just parse string, like text or code or anything, but it didn't really have a way to parse binary files. You could change it in a way where you could, and I did, but then there was performance problems because I actually ran it. And that's important because if I want to load something in a game, I want the loading to be really quick. If I have 10,000 model files and I need to load them all as fast as possible, well, parsing should be fast. And so I had to like kind of base it off of what they were doing here, and it's just the way I've been trying to do things. So you have parser of any type equals byte string returning that type. So I have functions here, any byte, so it's going to grab any byte from the string. Any int32 is going to grab any int32 from the string. Same thing with singles, and then so on. There's more to this, but it's not This is just something I just want to just quickly just show. And so it looks something like this. It's not, I don't know if it's idiomatic or not. It's just something I'm still trying to figure out. I find it a whole lot better than trying to not write it in the way that fparsec was doing things, since I'm basing it off of that. And actually ended up loving how fparsec works. And so I decided to just follow their route, but only made for binary, make it as absolutely as simple as possible, where there's hardly any code to do what I want to do, but it still looks the same as fparsec. And this just shows you that function called parse, and then it's going to take bytes, and that bytes is an array. Then I'm going to run the MD3 parser against that data. So that's what this is like really the whole thing. Everything else is just functions, just deep within each other. And then once I had this actually working, I decided to write basic unit tests around it. Took a model file that somebody made like a long time ago that's free and anyone can use. And I decided to just like, all right, if I can load that up and write a test around it, I'll feel confident that what I wrote there actually does parse the correct thing and doesn't go over the bounds of the array. And so I just wrote a test around it. And so the API to actually just parse a model is md3.parse the data. And that's all you have to do. And it'll just return you the entire structure and all the information you need right then and there, no questions asked. I want to be this simple. This is what I want to do. And my project. Make things as simple as possible. There's so much unnecessary complexity that unfortunately had to occur like in the original code base, probably because of time and who knows exactly what else. Of course, I wasn't there. And the last bit is actually just kind of a bonus thing, something I've been trying to figure out. As I said, I'm trying to find ways to make like F# and C communicating with each other as simple as possible instead of writing all that stuff I'm having to write. Even though I wrote abstractions around some things, it still is kind of painful. So this is just something I'm trying to figure out how I can make this process better. And it's not finished at all. I have no idea if it'll get any far. But it's a way you can just write inline C with a function declaration in F#, and depending on the return type and the types of parameters, that is what this C function will actually generate, and then it'll generate the necessary pinvoke calls for it automatically native to the system. So you can just write this, and then boom, you don't have to worry about anything else. It'll just take care of it for you. But of course, you're going to be limited to the different types that you're going to have to use. Like you can't pass in, a normal, crazy, .NET type, and it won't be able to figure out what it is. So you just have to only pass in, int, N64, byte, single, or string, and that's it. But this is just the route I'm going to try to go in order to simplify some of the hard problems I'm facing. And this is just going one direction. The other direction, I'm not sure. But if I can get this working well in just one direction, I think I may be able to find an elegant solution going the other way. But that's just what I've been just exploring. Okay. So just some links to my GitHub, to the Quake III project. You can, I'm absolutely welcome for anyone to come in and work on it. I don't care if you don't know anything. I want you to learn and have fun doing so. That's really all I want, is for people to learn and enjoy what they're doing. And the next link is a Quake III source code review by Fabian. And I've read this multiple times, and it's very helpful to give an overall construct of what the engine is doing in all these different places. You understand what's going on at a high level. And I think that's really useful. Okay. That is it. That is my talk. If anyone has any questions about anything?
So what are the disadvantages of inlining any arithmetic function mathematically?
Is that you have function overhead. If a computation is being called, 10,000, 100,000 times, you could waste, half a millisecond of time, and that half a millisecond of time in a game is actually a lot, and it's very important. Even just saving just 1 millisecond would just be very important. So it just gives you function overhead. That's all it does. Yes.
A couple questions. One, did you find a lot of examples of, so the tr.or that you found,
Yeah.
that was an example of a global that was used, but as kind of as a read-only, there was no side effect on the way out. Did you find other examples where they're changing or modifying globals?
Yes, that was just a simple example just showing that those same functions that you saw, there's loads of them. Not just that one, there's a whole lot more, and they do some really strange things just to get stuff to work for the reason that you can't actually see. But there are a lot of places that you can actually see something very similar to what you saw there.
And have you been able to solve those situations?
In order to really solve that situation, once you've written everything purely, like I have here, and you see that you have all these arguments being passed in, it's like, do I really need all this? And you find out which ones that you can actually break apart. And so now you have these small functions. Instead of this whole gigantic thing that take a bunch of stuff, now you have these small functions that do exactly what you want this thing to do. Once you start doing that, then you can kind of solve the problem that was already there. And that's something I'm trying to figure out myself, because I'm new to functional programming as well, and that's just one way to solve it. The other way is just you have that huge global state. In the F-sharp code, it's a record, and everything on there is immutable, so it's completely safe. I mean, you don't have to worry. But when you start using and start changing those weird things, like as you saw in C, I mean, you start seeing that, wow, I'm making copies of this global thing all over the place, and then you go, this doesn't really feel right. And so that's when you start thinking, that's where you actually start breaking these things out and actually finding a better solution to do the thing that you actually want to do. That's the best abstraction I can give you. Is that?
Yep. Okay. So actually, one other thing was you mentioned before about some delays in the play pause, and I'm not quite familiar. I don't know F-sharp at all, but does it do garbage collection?
Well, that's up to the runtime, the mono runtime, or the .NET runtime, and how the garbage collector works. There's a lot of options you can choose. I'm not sure why it does the intermittent pause when I'm running the F-sharp interactive embedded in there. But if that was gone, everything would run smooth and would be no intermittent pauses, and the garbage collector doesn't feel like an issue there. Yes.
Presumably, since you're writing material, you're making a lot of copies of it.
Yes.
And so, have you tested to see what the memory usage is in your Sharp version versus the C version?
What the performance difference of it?
No, the memory usage.
Memory usage, once you boot up the mono runtime and start loading everything up, I think Quake uses like somewhere around like 96. I think it got increased to like 146. If that answers your question. That's what I remember.
Maybe that's the garbage collection.
Yeah, you start seeing things increase a little bit, and then go back down, see things increase and go back down. And those things are running concurrently, so there's no like intermittent pause when you're running. So that's kind of nice. And Mono's SGen garbage collector is actually a whole lot better than their previous one. And actually, when I first started this, I was running an old version of Mono, actually a beta version. And then they came out with the official one, and I replaced it. My frame rate of whatever I was working on, everything went up probably 30% just from that. And so I'm like, it actually kind of made me feel comfortable, like, okay, I think they're solving some hard problems over there. I think this whole worry of GC, I think that's starting to go away a lot more now, since they're really trying to solve it. And I'm trying to see if there's any problems in that as well.
So you didn't find any situations where you were using the OO aspects of F# at all, right?
Yeah.
Okay.
I try to make everything as pure and as idiomatic to F# as possible, so I can learn it. Otherwise, if I'm trying to write, I'll just write a little bit of OO, maybe a little bit of functional. And no, you can't do that. You got to go the whole purity route in order to understand exactly what functional is. That's actually why people tell you to learn Haskell, because it forces you to do that.
So one of the other questions I had was when you're using an embedded FSI extension, and so you can basically kind of hot swap your code whenever you need, and all that resolution is done automatically for you, or like it just shadows the old copy of your code?
It'll shadow the old copy.
Okay, gotcha.
It doesn't like completely remove the thing. I mean, it can.
Right.
Yeah, it does just shadow.
Awesome. Okay.
So I'd like to ask a little bit about the approach you take to doing a reporting project like this. You know, you're faced with this huge code base, right? And you have to start somewhere, and I imagine you want to get hold of something and then call something else, and then call something else. And do you try to sort of work your way down to, do you pick a section and then try to work your way down to the leaves and then back up, or?
I go down to the furthest point possible, and I go outward. Instead of like starting from, somewhere in the middle, but then there's some stuff like other function call that could change state to something else. That wouldn't be, that's not true at all. So yeah, I have to go all the way.
So you're constantly kind of moving back the frontier of where F# and C# are interface, or and C are interfacing with each other.
Yes. I was wondering, like that, like M object is R and those like macros you have there.
Yeah.
Did you write all that, or is that like in a library
I
somewhere?
had to write it all.
I see.
Yeah. I shouldn't have read them all. I want somebody to please. I actually want it gone. I want someone else that's actually knows how to solve that problem better than I have. It's just me, I'm a bachelor, I go home, I got no responsibilities, I'm gonna sit on my couch and like, all right, M object, let's just go, let's go. And that's a horrible idea for me to write that.
Seems to work.
Yes.
So what surprised you the most about F# in this project?
Really functional programming in general. That's like as I described before, mutability and referential transparency, just those simple constraints and rules really make a whole lot of difference in the code that you're writing and the way that you think. Now, F# not being pure, it's kind of hard to enforce that discipline. And I just made it work because I really want to use this language because I can also use it at work because I do dynamic development as well. Right. I mean, that's the best answer I can give you there. It's really just learning functional programming and knowing what it really does give you versus, oh my gosh, object-oriented programming. Yeah. Anyone else? Yeah.
What about using the Mono, like SIMD library? They have like vector operation in there, and use like the SIM register.
The SIMD, is that what you?
Yeah.
I've actually looked at that. It's one of the first things I've actually tried. Mono SIMD is actually insanely fast, but the problem that I had with it is that they had things in there that didn't exactly want in my code base. There's just certain, like you're sort of constrained when you use Mono SIMD because it's directly, completely tied to the runtime. Meaning I can't go write my own little SIMD thing to use Mono. Those things by naming conventions, I think, are directly tied to it, and I just kind of felt like I kind of don't want to be completely tied to that. But there has been talk, I think it was either with Miguel or with Don, I think they may have discussed things with SIMD and how it can be like implemented a whole lot better than what the existing library is, to see if we can actually make this thing work and let people choose how they want to use those types of operations. Or something where the runtime knows what CPU you have, and so therefore I'm just going to put those proper SIMD instructions and run them because I know what CPU you have. there are things like that could happen. To answer your question, I did try MonoSMD, but it just didn't feel comfortable, and I kind of wanted to understand what it's actually like to write like linear algebra and implementations for those common functions in F# and see if they're elegant. And if they are elegant, imagine consuming them and how elegant you can actually you can go further. If you have your base thing already really elegant, anything above that, I would feel really happy about. But,
Yes. You sort of answered this already, but have you been in a situation where you have a global state and so the C code is doing a destructive update of this global state, but the state is so huge that you cannot just afford to return it, but also it is so complex that you can't just break it down into small pieces and only return that piece.
Right.
I had a concrete case where I'm trying to move a code which is uses destructive updates into a functional code with immutable states, and I have a state which is 16 gigabytes. And I have a function which can edit this 16 gigabyte, which is going to edit maybe 100 bytes anywhere in this 16 gigabytes.
It's good. Then you're toast. I can maybe give you some advice on that, because I'm actually having. The problem that you're having is probably the exact same problem that I'm having right now, because I'm at a blocking point. That's why I'm trying to do the whole interop and make it a whole lot smoother. The whole global state, is insanely massive, and I have to make copies of it. Then there's collections. These collections is just an array, and they also have allocations from somewhere else. Mapping that from unmanaged to managed is, it's okay. Going the other way is just impossible, because if I add something to that collection in my managed code, how in the world am I going to represent that back in the memory that's being used on the other side? That's just, it just won't work. What you would have to do is destroy the entire global thing and make that whole state be locked in on Mono or .NET runtime and make it stay there in the idiomatic way, and let everything else that was native there use that instead of going the other way around. That's what I've been thinking about. I don't know if it'll work yet. I'll find out, and I'll probably burn in a fire while doing it. But that's the best idea I can come up with there.
Thank you very much. It's been great. Thank you.